Okay, this is a pulley from a Jacob Guthart 1779 to 1867 tall case clock, and as you can see, the pulley is pretty sloppy, and I'm going to take this apart and install a butter bearing, and I want to see how it works out. So we're going to get started on that. Meanwhile, I'm going to pause the camera while I knock the rivet out. It's not really a through rivet. It's an extension on each side of the arbor. It's one solid arbor the whole way through. So I'm going to pause the camera and get this apart, and then we'll come back. Okay, I got this pulley apart, and you can see there is quite a bit of slop in the arbor, and what I'm going to do is take the rest of this arbor off of this stirrup, and I'm going to have to, let me get something to point with here. I'm going to have to turn this down to a smaller width because I want to make it the same width as the butter bearing, so that there's no side play. Plus, by doing that, I'll take a little bit off each side. It'll give me my, by doing it that way, it'll give me my rivet back. You know, because I'll have more of an extension then on each side. So I'll turn the camera off again, and I'll get back to you. Okay, folks, I have the arbor out of the pulley, and I'm going to put it in the lathe and shorten the center section to the width of the butter bearing. It's already, I tried to bit the bearing, I have a bearing here, I tried the bearing on it, and it already fits. In fact, it's a little bit loose. So if that doesn't work out for me, I may have to use this piece here that I made from brass. I have it, and it is a good fit. Butter bearing fits on there nice and tight. Just had it on there we go. Fits on there nice and tight, and it's exactly the right width. And the only problem is, as long as I have enough of rivet sticking through in order to peen it over, is what I have to worry about. Otherwise I'll have to make another one if I can't get the original steel one to work out. So I'll be back again, and then I gotta work on the pulley and make the hole large enough to accept the butter bearing, and I'll explain what I'm going to do there when I get to that. Okay, so I got this cut down now, and whoops, let's see if I can focus this a little better here. I got it cut down to about the width of the butter bearing, and we'll slip the butter bearing on there, and it's a pretty good fit. So now I'm going to work on the pulley. Now what I'm going to do with the pulley, I haven't had a whole lot of luck. This is a 10 millimeter, the butter bearing is 10 millimeter OD, and I haven't had a lot of luck with drilling a 10 millimeter hole and then have the bearing fit nice. So I'm using a 25/64 drill bit, which is one size under 10 millimeter, and then use a reamer. Let me get those tools. There's the drill bit, and then I'm going to use this reamer to bring the hole to size, and so that the bearing just presses in a little bit with a little bit of thumb pressure, and so I get a good fit and no wobble. So I'm going to get to that, and we'll see what happens. Okay, back again. I drilled the hole out with the 25/64 drill bit, and I put it in the lathe and took off some of the burrs that were around the hole from where it was worn so badly. Now if I try the butter bearing right now, it's not going to fit. You know, the hole's too small. So I'm going to ream away. Okay, I laid a dime underneath the pulley to make up for the curvature of the pulley while I put my Loctite on, using 271 Loctite. I don't know if you guys can see anything here, but I gotta be careful so I don't get any of this in the bearing. So my hands might be blocking. Working out pretty good because there's a chamfer there, and I put it up high, put the Loctite up high, and it runs right down into the groove of where the bearing enters the And there's the pulley. I'm going to do this side. Okay, I have my butter bearing installed, and it's sat for over 24 hours. I cleaned it up a little bit, buffed it. Bearing is working nice, and I'm going to put it in the stirrup now with the arbor in there. Spins pretty darn good. So while I'm putting the stirrup on and riveting these arbors over, I'm going to turn off the video camera because it's going to be a little difficult to use both hands hammering and trying to talk at the same time. So I will be back. Okay, I finally got these pulleys finished. I want to compare one of the pulleys from that I bought new from Wardell's, and I bought one from Meadows and Passmore too, but they were pretty much identical, so I'm just showing the one. And if I spin the one from Wardell, and it's done, and I spin the one with that I made up with the butter bearing in, and it went a little longer. Now let's count. 1 1,000, 2 1,000, 3 1,000. 1 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000. So it's a lot better, and it's a tight pulley. You can't see the bearing. You can see something, but spins pretty good. And then you got the one from Wardell. And it's nice and free, and this is oiled. I oiled this one, but it doesn't spin near as long and as free as the one with the butter bearing. So, and it still looks pretty original as far as the arbor that I put in and peened over. It was a lot of work. It was a whole lot easier to just buy new pulleys. But sometimes you have to try things and see how they work out. Maybe next time I won't spend the time that it took to do this. But it is a clock that's very old, from the probably late 1700s or early 1800s, and I wanted to try to keep it looking original. And the two pulleys as you can see, side by side. I mean, the owner probably wouldn't have known any difference, but at least this keeps the original parts with the clock. And I will do the other pulley, and will probably go a lot faster than this first one did, because there was some experimenting to be done.